So yeah, my name is Guillory, and I didn't mean to start a company. It wasn't supposed to be like this. I started building 3D printers in my garage as a hobby 3 years ago. And turns out there's actually a niche for large format 3D printers. And that's what I'm here to talk to you today about. So here's 5 methods of creating in-use parts. So we have injection molding, CNC machining, metal casting, and composites. And 3D printing can fit into all of these industries very specifically. So the first one we'll talk about is metal casting. Metal casting is one of the oldest forms of making any product on Earth. And so essentially you have a sand mold or pattern or ceramic, and you pour molten metal into it. And this technology is so significant, they named entire ages after it, the Bronze Age, Iron Age. CNC machining takes a chunk of material, and you have a computer-controlled machine that comes around and cuts that material away. And this is known as traditional manufacturing or subtractive manufacturing. The next one we'll talk about is injection molding. So injection molding takes something that a CNC machine makes. It's either aluminum or steel, and it forces plastic into it. And after the plastic cools down, the part pops out, and you can have large in-use parts in a matter of minutes. So this is the best way to mass produce parts. Composite layup is more of an aerospace or an automotive industry. And so they actually lay up carbon fiber, Kevlar, or fiberglass into sheet metal or a CNC mold, and then they vacuum form it down. This is the world I live in, 3D printing. And so the types of machines that we develop actually take a filament of plastic, it melts into a pattern, and builds it up layer by layer, and you have an end-use part in a matter of days or weeks. I believe the future of additive manufacturing can fit into, or blends itself into every form of traditional manufacturing. And I'll show you exactly how that works. So the first industry we'll look at is metal casting. And so metal casting is such an old industry, but these wood patterns you see right here, well, they're normally wood. That would take them weeks or months to create by hand or with a CNC machine. We're able to go from a CAD file to a steel part in 2 days. And that's the thing about 3D printing, is it's exponentially cheaper and faster than any other form of manufacturing. CNC machining, right here, this is a part we made for a startup here in Colorado Springs. And they couldn't afford a CNC prototype, so they came to us. We made this for a fraction of the cost in a matter of days. And they were able to test out their product with this part. So it was an end-use part. The composites industry. And this is a new one for us because that's a new industry as well. So composites require really high-temp plastics. And we can 3D print the molds that these plastics go into. And they can take the high heat and high pressures of an autoclave. Same thing with injection molding. Those green parts, the cavity and the core, these were made with a 3D printer. And so you have lower temp plastics that are injected into higher temp plastics, and you have an end-use part. And these are good for hundreds of parts, maybe not thousands. But the problem with 3D printing, and the reason it hasn't taken off, is because it's a slow process. It is painfully slow, and you can only melt plastic so fast. And for example, this bucket, it took 5 days to make it. If you were an injection mold, it would take a minute. Now, what I see the future of additive manufacturing going is the machinery. So if we advance machinery, we can advance the industry. And so we've built the fastest 3D printer in the world here in Colorado Springs with the help of a company called Autodesk. This is another part of our research. This is the pellet extruder. And this actually takes raw resin that is the same as the injection molding pellets. And we can print that extremely fast, but the problem is the surface finish is bad. And so on the Cronus, we have 5 print heads instead of 1. Now, it's revolutionary because this is the first machine of its kind in the world that can work with an infinite number of print heads on 1 machine. And so we've now gone from a prototype, a very big prototype that would have taken a week and a half to make, to something that can be produced in 3 days. And there's a picture of that coming up. But another thing is we can make not just 1 big part as a team, but we can have 5 individual parts printing, or 20, or mass production of parts. And this is the robotic arm I was talking about for ABB in Sweden. And so it took 72 hours to make this. And it has very high detail, very high resolution, and it can be used as a prototype or an in-use part if they decided. The real advantage of this, it takes us from the prototyping industry into end-use manufacturing. So if we can cut costs, cut time, we can make end-use molds, patterns, final products in days instead of weeks. And so where do I see the future going? Like I said, it's wide open, but with additive manufacturing and advancing the machinery that we have already done in the past 3 years, yeah, we'll see where it goes. Thank you.